All right, so we're going to go ahead and start. We're waiting for the research presentation to be shown on screen again. Yeah, the research presentation, please. 06. Yeah, thanks. Okay, so we're going to move on. We just finished before the lunch break on population structure, and now we're moving on to the second aspect of the biological presentation. Before we continue, we have time this afternoon for this presentation, followed by the next series of presentations, the fisheries dependent and fisheries independent data. And we're going to try to finish on time at 4 o'clock. So now it's 11:30. We have, a good 2.5 hours to wrap everything up. Because at 5 we have the dinner, and we're going to let you guys have a little bit of time to maybe even get back to your hotel. The restaurant, I've been told, is walking distance to where you're staying. And the reservation there is at 5. So again, we're going to try to finish here at 4, and it's 1:30. Yeah, what did I say? Oh, no. I guess I'm still in Hawaii time. No. No, it's 1:30. Yeah, you're totally right. 1:35. So. All right, so the next item that we want to show you is our recent work on maturity. So this is part of a big project that started in 2017, actually, about 5 years ago, that had as its main objective to better understand the reproductive biology of female Pacific halibut, with two specific objectives. The first one, the one that we're going to be talking about today, is to revisit the maturity schedules to determine really the age at which females are starting to belong to the mature part of the population. And then the second one, something that we've actually started collecting samples for, but we haven't really started the analysis, is fecundity. So fecundity is the estimation, probably the better estimation of egg output that feeds into the stock assessment. So today you're going to hear from Colin Jones about our recent work on histology-based maturity estimates. So Colin, you're welcome to come here, or I can work the slides. Yeah.
Yeah, right. Got some exciting updates regarding our updating of maturity estimates for female Pacific halibut. First, I'd just like to thank the current RAB members that have helped in collection of some of these samples over our summer months during the FIS over the last 3 years. So what are we currently using for our maturity estimates for, are you a, oh, I'm seeing that, and I'm seeing it different on the screen.
Yeah.
It's not moving. Yeah, it's just not moving up on the projector.
Maybe you could actually use that mouse. Yeah, use this one. Yeah, use the mouse.
Okay, so I'll look up there, not on the screen. Yeah, so our currently for our maturity estimates of female Pacific halibut, over a long decadal history on our fishery independent setline survey, we've been taking visual assessments, macroscopically visual assessments of females caught on our survey. And so currently we have 4 distinct stages of females, and that's categorized as 1, 2, 3, and 4. One's being immature, and 2s, 3s, and 4s classified as mature females, which run through the developing to the actively spawning to the resting phase for those females. In using this information, Ian currently in his stock assessment, the figure on the right is the current maturity ogive that we're using to estimate age at maturity for female Pacific halibut. And as you can see, what our current A50 or 50% maturity estimate right now is 11.6 years old. And to note that this information was collected from data back in 2002 and 2003, mostly from reg areas 2C and 3A. And so what we wanted to do was use kind of an updated approach using histological methodology to update our maturity estimates. And so what the IPH did was we conducted a study to categorize the female reproductive development using histology. And what you can see on this table, it's a little small, but basically it's broken down into 3 distinct growth phases and 9 different developmental stages. And so for females, the immature stage is the primary growth phase on the top there, up to what we consider to be cortical alveolar. And then once the female gets past the CA phase and into primary vitellogenesis, where you start to actually see like lipid globules within the oocyte as the oocytes are getting bigger and developing, that's when a female is classified as mature. And once they reach that secondary growth, and then eventually into oocyte maturation and the release of the oocyte into the water column. And so it's important to note that when we're using histological methodology, females are directly assigned to a developmental stage based on the most advanced oocyte stage present. Because what you'll see under the microscope is that there could be different stages of oocytes. And that's because Pacific halibut are batch spawners. And so basically they are forming a distinct batch of eggs to spawn for that year. And so while you see the progression of that histologically, you'll also see immature cells as well, which could eventually become mature like in another years down the road. That's why they're batch spawners. And so using this new information, what we were able to do was starting in 2022, we went out and collected maturity samples on the Fishery Independent Setline Survey. And in 2022, which is represented by those red dots, it covered all 4 biological regions. And so that was why that year specifically was very important for us, was so we were able to get histology samples across all 4 biological regions. And then we collected samples again in 2023. But as you recall, the 2023 FIS was reduced to only the biological regions 2 and 3, which are distinct by those blue dots. And so we also collected samples this year again, which I'll talk about towards the end of the presentation. So using this information, all the samples were scored. So every female was deemed whether they were immature or mature. And what we were able to do was populate new maturity ogives by biological region. So what you see on the figures on the right is you have age on the x-axis and proportion mature on the y-axis. And the data was binned for these model outputs. So those circled dots indicate at least 10 females. It's not raw data points, just for clarification. And also you see those vertical dashed lines. Those indicate what we consider to be A5, A50, and A95, or age at 5% maturity, age at 50% maturity, and age at 95% maturity. So it kind of gives a good visual indication. You can see differences between the regional curves. And we decided to use what's called a generalized additive model, which provides a little bit more flexibility in the curvature of the model rather than a simple linear model. It ended up being the best fit model. So we've decided to go with that as we proceed through these generation of ogive curves. And what you can see is, I'll start on the right-hand side. So on the top right, you have region 3, which has a very steep ogive curve. And you can see that's indicated by an A50 value, which is less than 10 years old. And also in region 4B, we also have a pretty steep ogive curve with an A50 value just over 10 years old. Then if you shift to the left-hand side with region 2 and region 4, you'll see that the curves are a little bit more not as steep. And you can, and that's indicative by the A50 values of regions 2 and region 4 being anywhere between about 13 to 14 years old. So this first year of data in 2022 definitely gave us a good spatial structure of how maturity is differing coast-wide within the convention waters of the IPHC. And you can see that specifically in region 3, the fish seem to be maturing at a much younger age than the other regions. And so, yeah, go ahead.
Just notice on region 3, why is there no A95 line?
Yeah, so that's a one distinct aspect of a GAM model, is it provides a little bit more flexibility in the curve. And so you can see as you reach about 15 years old, and then once you get past 15, there's a little circle there that kind of drops the proportion mature down, and the model fit is trying to fit that data better. And that's one of the downfalls of only having 1 year's worth of data, is the model is trying to do its best to fit that year's worth of data. And you'll see that there's a much bigger difference once you add another year to the model, and it kind of smooths it out a little bit. So then if you look at the female developmental stages, so as the female progresses through the summer months of the FIS, what type of developmental stage you see between each biological region. So each of these figures is by month on the x-axis, and the proportion of number of developmental stages that you see. And so you can see that on the bottom are the dark blue and blue colors, which are the immature fish. And then as you get to the green and start moving up towards the yellow and red colors, those are mature females that are more developed over time. And so what you see here is that we found that there's earlier maturation in the females for regions 3 and 4B. And that sort of makes sense because that's similar to what we found in the steepness of those ogive curves. So we're finding that the females are maturing faster that year. And so and it's forcing them to also mature at younger ages. And then another distinct thing that we found was that there's a clear oocyte development the oocyte development is progressively getting faster as you move from the east end of the stock, which is region 2, to the west end of the stock. You can see on the far left figure, region 2 is showing a lot of immature fish in the late spring, early summer months, and as they slowly progress through maturation over the later summer months. But then if you look at region 4B on the right, you see that already in the month of June, over 50% of the females that we caught were already within the vitellogenesis or upper vitellogenesis stages. And this definitely could have impacts in timing of spawning, potentially. It's something that we're definitely going to look into as we collect more years worth of data within these biological regions. Because once a female is hitting VTG3 or germinal vesicle migration, which is that top red bar, you potentially could expect that female could be spawning capable within 2 to 3 months of that period of happening, which could be indicative that they're there could be earlier spawning maybe going on in region 4B, which we just don't know. We're not certain of yet, but it's a potential. So then what we wanted to do was use the same GAM model, but add a year effect. So including both 2022 and 2023 to the maturity ogives. And so I'm just comparing regions 2 and regions 3 here because those were the only 2 regions that we have data for both those years. And as the question indicated earlier, you can see and specifically on that top right curve, which is the new model output for the 2022 data in region 3. You can see that the model has smoothed out that data. You now see an A95 value at about 30 years old. And so basically, if you look between the 2 years, you can see that in 2023, we did find more females to be mature rather than immature. And this caused, in particular, region 2's curve to be more steep, in which the A50 value dropped about 3 to 4 years old for the females between the 2 years. And this is why it's important to look at temporal changes and look at multiple years, because there could be some shifts going on in these regions over time. But if you look at region 3 was very consistent across both years. So that was kind of neat to see how temporal changes could be affecting the regional curves. So then if we look at female developmental stages for 2023, you can see that there's very similar trends to 2022, in that region 2 is showing a slower progression of females from the late spring to the later summer months. And region 3, is showing earlier maturation and development for those females. So then now that we have these 2 years of data, what the ultimate goal was to create a new coastwide ogive for Ian's stock assessment. So what you see on the right figure there are the 2022 and 22 and 23 data pooled by region. So those are the regional curves with a combination of all samples collected across both years. And then what we did to create a new coastwide ogive was we used Ray Webster's space-time model, which he uses to create his abundance and biomass estimates for the fifth space-time model for years. And we use that abundance estimate to create weighted regional ogives in order to create a coastwide curve. And so this black solid line is that new coastwide ogive. And what you'll see is that, the colors on those figures are kind of small, but you see that curve falls roughly between biological regions 2 and 3. That's because those 2 regions have the highest current abundance estimates for the coastwide stock. And so that it's weighting those ogives more, and that's why it's fitting that curve more towards those 2 regions. And what this new curve gives us is a new A50 or 50% maturity value of 10.3. And if you recall on that first slide that I showed, our current estimate is at 11.6. So it's actually dropping that A50 value by over 1 year. And so that can have some pretty strong implications for the stock assessment, especially since we currently have a large abundance of smaller fish. And so this could be indicative that some of those smaller fish are actually more mature than what we thought. And so it could have potential for maybe increasing our spawning stock biomass estimates. And Ian can talk about that a little bit when I'm done here. But so once we created that, we also want to continue to keep looking at different trends over time. So yes, this year in 2024, we went out and collected samples in biological regions 2, 3, and we're able to get samples back out in the Bering Sea in region 4, which is great because we missed it in 23. And so we'll be able to incorporate, these samples are all back in our lab now, and I'm starting to go through them and score them now. And the hope is to get all this data for Ian's stock assessment, full stock assessment for 2025. So just some bullet points for conclusion. So we do see that there are spatial differences among biological regions for maturity at age. In particular, we're starting to see seeing that there's a lot younger females maturing, in particular biologicals regions 3 and 4B in comparison to 4 and 2. We are seeing that there's earlier oocyte development from the west end of the stalk to the east end of the stalk. So the females are showing earlier progression through the annual reproductive cycle on the west end of the stalk compared to region 2. And our new coast-wide ogive has lowered our A50 value compared to the visual and field classifications on our set line survey. And then once again, the samples are currently being processed from 2024, and Ian is conducting a new full stock assessment model for 2025. And so this data will be incorporated into that assessment. Yeah, and just before, if anybody has any questions, I'll just reiterate what Josette mentioned at the beginning was, now that we have new maturity estimates, the next step is fecundity and egg output. And so over the past 2 years, we've been collecting fecundity samples on our FIS. And we also just did a fall pilot study in Northern 2B to collect some fecundity samples that are later developing females. Because the ultimate goal of that is we're going to build what's called an autodiametric curve, which is basically you take the average oocyte size for a female, and then you take that per gram of tissue, and then you extrapolate that to the total gonad size. And that gives you total egg output for that female. And what we don't know currently for Pacific halibut, which has been shown in a lot of other marine fish species, in particular some like West Coast rockfish and some New England flatfish species, that they have, as the female gets bigger, they call them big, fat, fecund female fish. The expectation is that they have more egg output. And we just don't know if that's for certain. And so we're hoping to demonstrate if that's true or not for females in Pacific halibut. And yeah, I'll take any questions if anybody has any. Yeah.
Slide 13. That for 2022. And then, so look at region 2, third column, the little bit of red on top. And then if you look at 2023, same kind of thing. Does that say that there's virtually no spawning females in area 2?
No, this is showing the progression of female development through their annual reproductive cycle. So what this is showing is the developmental stages through time during one annual reproductive cycle. So what you'll see here is, like, if you look at the region 3 there, the second one to the left, you'll see that currently we are finding that in region 3, you see that there's up to about 75% of females are in the vitellogenesis, or they've hit the mature phase of reproductive development in May. But then if you look at region 2, if you look at May on the left-hand side there, it's just slightly less than 50% of females have hit that vitellogenesis stage. So what this is showing, and similar trends have been shown from 22 and 23, is that the females in region 3 are showing earlier progression through their annual reproductive cycle than in region 2. So region 2 is showing that the females are later to develop than in region 3, which once again could potentially have implications for timing of spawning. Because if they're showing later, if they're showing that they're developing through vitellogenesis later, it could mean that potentially females in region 2 could be spawning later than maybe in region 3 or in other regions.
So what do we do with that information?
Yeah, that's a great question. So it's I might start and Ian can fill.
Stay tuned.
Yeah, stay tuned. So we're the Secretariat is currently running through I would say maybe different scenarios of how we could implement this into the stock assessment, because there's some big implications. One being that currently our current maturity estimates have been using visual field estimates for decades now, and now we're incorporating a new methodology, and also the way that we're currently classifying our new coastwide ogive is using the FIS space-time model, and that index only goes back to 1993. And so Ian obviously has a historical data set for maturity that dates back way earlier than that. And so we're trying to figure out ways how we can best input that into the assessment. I don't know if Ian has anything to add to that.
Could you go back to the slide with I guess it had region 2 and region 3, and it looked like in 1 year, yeah, these ones in 2023 in region 2, it looks like that A50 is right below 10, but then it's right below, maybe that's like 13 in 2022. That's a pretty significant difference, though. I'm wondering, do you guys have any ideas why there might have been that discrepancy between the 2 years?
Yeah, there might be a couple of things going on there. One is there potentially could be that type of difference in how many mature females are per region. Another thing that is going to be factored in here, especially as we get more years worth of data, is timing of sampling. Calendar day and timing of sampling could have an impact here. Because as you might recall from previous presentations on our maturity studies, our original reproductive assessment project was done in the Portlock Charter region. So that's like Central Gulf in the middle of region 3. We were basing our timing of sampling through the FIS originally on that original project, because that project indicated that the FIS was a good a resource for us to collect samples, because that project had indicated that females that were going to mature for that year were hitting maturity during the time of the FIS, so from May to like early September. But now that we've been able to collect samples throughout the whole coastwide of convention waters, we are seeing that obviously development through time for each year is different regionally. And so the timing of when the samples are collected could play a role here. And it's something that we're definitely going to look into. We just don't have a definitive answer to yet.
I hate to do this. I hate to put you on the spot like this, but looking at this, even with 2022, 2023, if we're having, maybe a higher harvest rate in region 2 than say region 3, aren't we having a kind of a disproportionate effect on the spawning stock? Like, we kind of, it seems like we might be making some issues worse if we're not accounting for that and how we're distributing allocations and things.
I mean, you do bring up a valid point. It's I think as we get a better feel for how these curves change over time, what we don't know is right now I'm only showing you 2 years of data. That's just a small temporal window. We don't really consider that to be a trend. And so what we really don't know is how much is region 2 and region 3 really fluctuating over time. I mean, if once we get like up to a decade's worth of data here, we can really see are those differences narrowing, or are they getting bigger, or how are we seeing that over time? And if we are seeing these trends to be true over time, it definitely could have an impact on how we're pulling females out of the water, and specifically how much and where we're taking them from.
Brian, what was the point that you were making there? I just didn't quite catch it.
Oh, just that if we're, say, fish are maturing, I don't know. This isn't, you can't say that it's a trend because like you said, we only have 2 years of data here. We'd need, many more years of data to say that there's any trend. But if there was a trend, and say in region 2, fish were maturing on average 3 years earlier than they were in region 3. If we were fishing at a higher harvest rate, if we had a higher harvest rate in region 2, we would have a disproportionate effect on the spawning stock biomass because you'd be fishing more females that are actually spawning than in other areas relative to the number of fish you're pulling out of the water, I guess, or number of pounds.
I think it's probably a little bit more complicated than just looking at the maturity schedule because the fish are going to have different average growth rates in the different areas, and the age structure of the catch is also going to vary. But you're right in identifying that all of those things, a pound of yield in each biological region doesn't necessarily have the same effect on the overall stock. We already see that given the information we have about growth rates and longevity in the different areas. So that's certainly always a consideration in the back of the overall picture, is that a pound of yield isn't a pound of yield everywhere.
I guess what I kind of think about, makes me think about time of year when we're doing removals too. If we could keep our seasons away from the spawning times, I think, or because they tend to bunch up and they're easier to catch when they come into that realm too. Like right now at this time of year, as far as I'm concerned, we shouldn't be fishing, but I don't know, my thought is does it make sense if we could keep the season away from those periods of time so they could have a chance to do their thing, and then it's not like a salmon that dies. They just go back to living, but they've reproduced, and hopefully that's helping out the future.
I think you've certainly got a point that fishing on the spawning aggregation could be different catch rates. It could even be different demographics of fish. I'm not sure that we necessarily are doing more or less, having a smaller or larger effect on the stock by fishing around the spawning aggregations. If we're fishing to a fixed quota, the bigger effect is what's that quota. If we're going to catch the same number of pounds, it may not really matter if we catch them in the fall versus the winter versus the spring. With a fish like this, as you point out, they're not going to spawn just once. And so if we're really relying on fish to spawn and then catching them, we're probably fishing them too hard already. We're counting on a lot of these fish to spawn for multiple years anyway. So there's definitely some things to trade off there.
Great, thanks.
All right, thanks, Colin. So we're going to move on to the next item, which is mortality and survival assessment. And Claude's going to speak to the second aspect that you see here in this, again, complicated slide. This slide basically summarizes the work that we've done over the last 5 years. We started with a study that is already completed and we've already reported on. That was the estimations of discard mortality rates in the longline fishery. That study guided the next study, which is the one that Claude's going to talk to you about. And that's a very similar study trying to estimate discard mortality rates in the charter recreational fishery. So go ahead, Claude.
All right. So what do we
You
use?
may have to use the second mouse. Yeah.
Oh, how to go backwards? Can I go backwards? Here we go. All right. So for the guided recreational fishery and the non-guided recreational fishery, we have never had direct observations of discard mortality. So the way they're estimated has been based on a combination of discard mortality rates as seen from studies on commercial circle hooks, as well as combined with estimates from other recreational fisheries. And so we felt it was important to go out and actually ground truth that and make sure that those estimates were in the realm of the realistic. And so we in 2019, we did a survey of the charter fleet to better understand their gear practices and their handling practices on fish. And we found that the predominant hooks that were being used, 75 to 100% of the hooks are circle hooks, just as you see in the commercial fleet, followed closely by jigs that typically have J hooks. And then we looked at the way the fish were handled, how the hooks were removed, and we went out and replicated those in an experimental fashion out of Southeast Alaska, out of Sitka, as well as out of Seward in 3A. And we compared two different circle hook sizes, wanting to get a better understanding of how that impacts survival. So do the hooks, they catch similar size fish, do they have similar injury profiles, that sort of thing. We did find a significant difference of fish size caught by the different hooks. So as you might expect, you're seeing slightly larger hook or slightly larger fork length, as you see on the graph on the left, for a 60-knot circle hook than you do for a 12-aught. That was not seen consistently in all areas, but overall, the whole pool of fish did show that there was, larger fish caught with a larger hook. When you classify, so when working with discard mortality rates, typically fish are categorized as excellent, moderate, poor, or dead. Each of those generally has a suite of, or a discard mortality rate associated with it. This is something that observers do. They go out and assess whether the fish fits in one of those bins based on their injury profile, how badly they're bleeding, things like that. When categorizing them by that, it was found that the smaller hook, the 12-aught, was slightly more common in generating less than excellent condition fish. But the reality is over 90% of these fish that were caught on this study were all in excellent condition, no matter what kind of, no matter what size of hook you were using. Yeah.
Were the smaller hooks just catching a gill or something, or they were swallowing it?
Yeah, so we thought we'd see significant effects on the location of that hook, so more gut swallowing or throat swallowing with the smaller hook. We did not see that in this case. There was it was non-significant, that level. There wasn't a lot of gut swallowing to begin with. I think we had 2 fish in total, so it didn't. We had a total of 361 fish that were captured as part of the study. We thought we'd see differences in how far that hook reaches in. So will a larger hook cause more eye damage, for instance? Does it reach in and affect the eye more likely? Again, we did not find a significant difference between the hook sizes on that. So even though you think physics might point you to that, we didn't find that in this study. We were looking for it though. So we also took blood samples from these fish, and we looked at 3 kind of stress markers there. So glucose is the fish's immediate source of energy. Lactate is a breakdown product of that energy source, kind of like when you get a cramp, you're building up lactate acid in your system. Cortisol is a stress hormone that's released to help activate glucose or energy storage to activate it. And again, we did not find significant differences by release viability between excellent, moderate, and poor fish. We did find increases in the levels of each of those indicators with respect to fight time. So those are the plots you see down the center there. So the longer the fish was fighting, the more of that product it had in it, particularly with lactate, which is not unexpected. Fight time was largely dictated by the size of the fish. So again, a larger fish takes longer to bring it to the surface, so you have a longer fight time. Those fish are also heavier when you're longer, they're heavier fish. So we did see positive relationships there, but we did not see any differentiation between the different predictive levels of excellent, moderate, poor, or dead. The final column of graphs there, it's a little hard to see, but there's 2 bars in each of those graphs. And that is representing if we go to the top right plot for glucose, the bar on the left was the glucose we saw on fish that are still at large. So they were released and they have not been recaptured. The ones on the right, we know for sure have survived because they've been recaptured. They were tagged, all these fish were tagged, so we can identify them again when they're caught. And that was what their glucose was when they were released. So it gives you a proxy of fish that that are recaptured. Are they in some way different? Do they have lower glucose levels? Do they have higher glucose levels, and so on? Again, for all 3 of those measurements, we did not find any differences. So they were not predictive in the survival likelihood of those fish. The levels that you saw in these fish compared to the previous study that Joseph mentioned that we've presented at previous meetings for glucose and lactate for the sport caught fish, they're about a quarter of the levels seen in commercial longline gear. And for cortisol, it's about 10-fold lower than what we saw in commercial longline gear. So those levels are quite a bit lower, but again, even in the commercial gear, those were not predictive indicators. We thought they might be in other fish species. They're not for halibut. Steve?
Are you saying that while you're sampling the tagging fish, you let a fish go and it got recaptured on the same?
No.
target?
So all these fish that we handled and captured, we took blood samples from. We assessed their hooking and release injury, like what injury had they sustained. We tagged them, recorded all that information, and we released them. We had glucose levels for all the fish that are still out there and have not been recaught. But since the study was done, we've caught a total of 38 wire tags and 7 satellite tags. Plus there was a total of 80 satellite tags out there. So we know which fish have been recaptured, and it's graphing those ones. So was fish that for sure survived and we've seen recaptured down the road, was its glucose, lactate, or cortisol different than its compatriots that we have not recaptured, and some of which may have died? So this was at the time of us handling them at the first time. The status of at large still or recaptured is a function of whether they've been returned by the fishery.
So they were captured subsequently and they were tested?
No, that's their test value when they were released.
Did you say that you recaptured 80 of 320 some that you tagged? Is that what I heard?
No. So I'll come to the tagging bit in just a bit, but essentially 80 of the fish out of Seward were tagged with a pop-up satellite tag, of which 76 provided usable data. 2 didn't get recovered and 2 didn't provide data that was usable. Of that group, 7 of those were actually recaptured by a fishery that while they were out actively swimming with their tag, they were recaught. And then of the remaining 280 some odd wire tags, we've recovered 38 so far. So it's a pretty high recovery rate. Yeah.
That's that stupid fish caught, right?
Or motivated fish. He's hungry and didn't mind what we did to him the first time. Yeah.
Could you reiterate what you said about the levels of lactate and cortisol between the recreational fishery and the commercial fishery?
Yeah, so the levels in the recreational fishery were either a quarter of the amount seen in the commercial or a tenth of the amount seen in the commercial. So much lower stress levels being seen in these recreationally caught fish. Now, that doesn't necessarily come as a surprise. These fish are, they're hooked and exposed to a stressor for an extremely short amount of time, right? And the longest one we're seeing there, you can't see the numbers, but it's essentially the longest fight time was 40 minutes. The average was about 10 minutes. See, this is a 10-minute stressor versus a multi-hour stressing event, right? And for an animal that's on hook and line gear, you would anticipate that they get caught, they struggle, they rest. They struggle again, but not as long. They rest a little longer, and that cycle continues until they're not struggling as much anymore because they're completely fatigued. So, so on to the tagging question. So there was 281 wire tags released across the viabilities. 38 of those have been recovered to date. That's a 13.5% recovery, which is fairly high for our historical tagging work. The satellite tags, 80 of these were released. Again, 76 provided data, usable data. 7 of those were actually recovered by a fishery before they had filled their entire memory. And if they did not get recaptured, at 96 days, they were programmed to burn a little pin, send the satellite to the surface, and dump the data to a satellite. And I get an email that says, tag XYZ has surfaced at this location. Here's its data. So the ones that were recaptured by the fishery, we get those tags directly, and we can look directly at what the animal was doing up to the point it was caught. And we know where we released it and where it was recovered by the fishery. Just to back up slightly and remind folks, satellite tags can carry a suite of instruments on board. These ones carried pitch and roll indicators. So that's the same sensor that you have on your cell phone telling you whether it's in portrait or landscape mode. And so for halibut, it's set to, if it goes past 15 degrees, that's considered a knockdown. And the tags get knocked down as the animal's swimming along. They go pop, 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 pop. And when it sends it to the satellite, I get summaries every 2 hours as to how many knockdowns occurred during that 2-hour window. If the animal died and it stopped moving, that shows up on the tag profile. If the animal died or stopped moving rather for more than 3 days, the tag goes, this animal's dead, I'm sending you to the surface. And I get that indication for both what was the cause of the tag coming off, as well as I can see in the data that the tag flatlined. Using those satellite tag data, we can estimate that the current estimate for excellent viability fish is just 1.35, which is ranging between 0 and 4%. That is a low level. It's about a quarter of the level that we saw for excellent viability fish in the commercial fleet, which was already an excellent level. It's a pretty low mortality. This isn't even a lower mortality. The mortality that's being used in the estimates for the fishery include other things. Not all fish are released in excellent condition. Not all fish are handled the same way. And so it's likely somewhat higher. Typically, you're seeing somewhere between 6 and 7% as the discard mortality rate assumed in the sport fleet. But we know certainly for the excellent viability fish, they have very high survivability. So that, I believe, is the summary for that part. Does anybody else have questions on this piece? Yeah.
Were any of your tags ingested and then recovered
Yeah,
by something else?
we don't have thermometers on these particular tags, so we wouldn't know if they've been ingested by another animal. So there are tags that do that, and you can see particularly when a marine mammal takes one, the temperature typically rises for one, and it stays very stable for a period of time until it's passed. We didn't have that sensor on board, so we cannot tell that. We had generally the tags reported the way you'd expect them to. We had one tag that once it popped up, they continue to broadcast their data until the battery's done. And we had one float over to Augustine Island, go right into the lagoon by the USGS Volcanic Seismic Center. And I actually reached out to them and said, hey, here's a space photograph of where this tag's currently reporting off the beach. If you can find it, I can get the readings every 15 seconds instead of summed up for every 2 hours. They haven't been able to find it, but they've been looking. I get an email each year saying, hey, we still haven't found your tag, but we're still looking. So they do interesting things, these tags.
What's the farthest the tag fish moved?
It's the one that you see for the wired tag fish. It's the one you see on the upper right there. For the satellite tags, the biggest movement we had in this one over a 96 days during the summer feeding period was about 100 miles. Yeah.
Is this assessment with tagging outside of the FIS? Is this a separate thing?
This was a separate project. Yeah. So we hired charter recreational vessels and their skipper and crewmen. And then we had 6 volunteer fishers on each vessel, fishing alternately 12-aught and 16-aught circle hooks. And then one of us would do all the sampling on the fish. Yeah, so we do tag fish on the survey. And again, it depends on if we're working on a specific project where we're targeting large volumes or not. We have been tagging a subset of U32s, so sublegal fish, and releasing those if they were not destined to be sacrificed to get their otoliths, so we can see some of the younger age groups and all that. I don't know that we did that this past year. We've also been doing a project where we've been taking a photo of the white side of the halibut's tail and the markings on that white side, and then tagging it with a tag that says, hey, take a picture of me when you recapture me. And that's part of a project where we're trying to use natural markings that you see on that white side of the halibut tail as a natural tag. So there's researchers around the world using animal patterns as a means of a natural tag. We know they're fairly unique, and we can tell unique fish in an offload of fish. What we don't know is the permanence of those markings. So as an animal grows, do the dots and dashes that you see on its tail, do they stay unique to that fish? Do they fade? Do you get new freckles on them? Do the ratios of how they stretch across that tail stay static as that animal gets larger? And can we use it over time as a de facto tag? And that's the question we're getting at with current releases of tags for that project.
Claude, with regard to mortality and survival, is there any correlation between the data you've collected on prior hook injuries with this program?
So with the prior hooking injury, we will assess a fish that we've just caught as having a current injury and a prior injury if there's one obvious. Sometimes there's obvious scarring, sometimes there's complete facial deformity, so to speak, where pieces are missing and have healed over. It's a bit of chicken and egg thing there. We don't know what that animal got exposed to, if it has a severe injury that it's healed up and is showing us, and they generally don't have a tag on them to tell us that. We have enough tags out there on the commercial gear that we might be able to see some of that, but we haven't gotten a whole lot of those back that had severe injuries, because you have a lower survival outcome with those. Not zero. We often don't have zero in the dead fish. There's often what we call Lazarus fish, where we think that fish isn't going to survive, and then someone captures it, even though we tagged it. So I'm not sure I answered your question there, but we can get kind of an assessment of how many severe injuries, if you want to call them that, are caused by certain practices. For instance, hitting a crucifier or a hook stripper. And we did that work on the commercial study that was listed there. But as far as how did those animals heal up and stuff, those tags are still out there, and we're still waiting to see if we can recapture some over time. Yeah.
Would you say your tagging frequency as far as the fish goes is, it remains the same each year, or is it economically driven to an extent? And the reason I ask that is like, in the case of sablefish, we caught almost 400,000 pounds this year, and we had 2 tagged fish, where in years past we'd have a couple dozen.
Right. It is not economically driven. So our sampling rate is dictated by what science we need from a given region. And then those that are sublegal and don't fit that sampling are then eligible for tagging typically, but not always, depending on how many regions we're doing and things like that. And it also depends if you're on a boat that's doing the tail tagging project, it would serve 2 purposes where you're both getting the image of the tail, and it was one of those fish that fit that category of not being subsampled. Some of our work in the past, like the pit tagging project, we set out 3 extra skates of gear on each set. So you might be fishing 8 skates of gear. The first 3 you tag and release every single halibut that you get. And then the next 5 skates are your typical FIS data generation. So we had different models on that in the past. We've also done tagging work on trawlers. I think we still continue to do some tagging off the trawl vessels, off the NIMS trawl survey rather, things like that. So.
Do you, considering commercial fishermen catch fish, and if they're over 32 inches, they keep them by law. Charter fishermen sometimes catch at least 15 fish and keep 1 out of 15. So would you multiply, depending on some places, you're only going to catch 1 if you're lucky, period. But would you maybe multiply by 15 the mortality rate for everyone that's caught in a certain, like, I'm not bragging, but at my lodge, we catch a lot of fish. And maybe the mortality rate should be much higher when you consider the amount of fish that are actually released.
Right. That's a good point. And what is the effect of cumulative captures and releases on a single animal? We don't know that. We have had reports of some of our tags being recaptured. Someone took a picture of it and let it go again. We're not encouraging that. There are other tags that other groups have done where they've got a multiple capture and release tag where it's got essentially tag XYZ repeated on a print, and you clip the last one off and you say, hey, I caught it this day at this site, and I let it go again, and it seemed to be in good condition. You know, they're suffering repeated injuries to the face. They're going under stress repeatedly. We sometimes, even on this study, recaught the same fish a few hours later. I think it happened twice out of 360 fish, but it does happen. We know it happens. What is its effect on DMR? I think you'd have to do a whole separate study on that. Certainly the turnover rate is probably higher than we think. The fact that we've gotten this many recoveries from this particular fishery on sport fishing grounds probably speaks somewhat to that. But I think it would need further work on that to truly understand the impact of that. But clearly generally the stress on the animal's pretty low. The injury they're getting is pretty minimal, and they're pretty rugged fish and recover from this stuff generally pretty well. Especially on seasoned charter vessels that they know how to handle fish quickly and handily. I suspect there's more gut swallowing on a vessel where there's not someone pointing out to you that you have someone on your gear. Like if you're letting it sit there and you're busy chatting and you're not paying attention, it's probably more highly chance that there's more gut swallowing in the unguided fishery than in the guided. But we don't have data for that, but you could postulate that. It would stand up to YouTube videos you see of different catch rates from different sectors. So there are questions there before you switch to just assuming a 1.35% DMR on excellent quality fish. That's not the whole story. So you got to factor that in when you're determining how to use that number.
So what number do you use to try to figure out the overall mortality for the charter fishing industry? Is there a particular number?
So right now they're using 6 or 7%, and part of that assumes a 4% discard mortality on the excellent quality fish. So I would argue we think that excellent quality fish have a lower mortality than that, although it's in the margin of error. So I think it's something we put out there and we have for discussions, peer review discussions, and see where that goes.
Before we move on,
Sure.
let's save some questions for later. I mean, we still have time for discussion, but for the sake of time, and we still have some presentations left before 4. Let's move on to the next one.
Yeah, so I'll give a quick update on the 2 fishing technology projects we're working on. While I'm speaking, I'll pass these guys around. This is the example of the hook timer. It was mentioned earlier. It's a device that has a little piece of electronics attached to it with a magnet. There's a sensor that when the fish pulls on the gear, it pops the magnet away from the main body, which triggers a clock to start running. You can pass that around and look at it. The O-ring inside of it can be adjusted for different weight of fish that you're capturing on the gear. Sure. And then this is just a set of and that one has an appendage hook on the other end of it, just for something to look at. And this is a suite of different sized appendage hooks and different angles that have been fished recently. So reducing whale depredation by protecting longline catches. This is a project we've been doing since 2022. We held an international workshop with over 70 participants back in 2022 from 6 different countries, looking for kind of different options to protect the catch rather than deter the whales themselves. Where most audible and visual things seem to just become de facto dinner bells, we thought, let's protect the catch instead of trying to scare the animal away. This led to field testing of 2 catch protection devices in 2023 aboard Al's vessel, the Pacific Surveyor. And that testing looked at deployment and retrieval logistics, optimal configurations to get the gear to perform as expected, and to look at the basic performance both on species caught and the sizes of fish caught. The 2 devices were a shuttle that you see on the left, which is essentially a large device that slides down the ground line. The hooked fish enter the front funnel end that you see there. They get released inside the device. The gear continues out the back, and it continues sliding down the ground line until it encounters a pre-installed stopper, and it rides that up to the surface. The second device is more of a shroud, and it's a modified type of long line fishing. So here you have the ground line going across the top of the picture on the right. You have a branch line with 10 hooks on snap gear that comes off of that. We have multiple branches that come off of it. And we had a shroud, which we made from a modified slinky pot where we cut the end out of one end and covered up the other end. And it slides down to cover the fish. And I'll just kind of go through a sequence of slides here to show the fish coming up, getting caught on the branch line hooks. Then as the ground line starts to be retrieved, the shuttle from water pressure, the shroud from water pressure slides down, covers the fish a bit like an umbrella, brings them up to the surface in that protected netting. Cutting to the chase quickly, the work showed that the shuttle is ready to go. It's a functional unit that can be used on a smaller vessel. That's an image of one of the units stowed on the upper left there. We had the unit instrumented with cameras and accelerometers so we could see how it was performing underwater, how fish entered the device, whether fish got excluded even from coming into the device. There's a picture of it being hoisted up back out of the water, and then it's dropped down onto the deck, and there's a trap door that opens up, and that was a catch, I think, of 17 halibut in that image, and 1 baker, that's a petrale sole right up on the top. And that unit was, so it was safe, it was usable, and it had pretty similar catch metrics to the control gear. So the graph on the left is the number of halibut per skate. We were fishing this in 2A, so we didn't have giant catches, but they had similar catch rates and they had similar length profiles that were being entrapped in the device. The shroud unit had a lot of safety challenges and a lot of things to work out. And so at this point, we're recommending further testing of this device, but not the shroud device.
How big was the ground line used with the shuttle? How deep did you go?
Well, we didn't get a lot of bycatch.
We got usual bycatch on both control and the shuttle treatment. So we caught some large skates, we caught petrale sole, some of the petrale went right through the device. But generally we were catching or in training around 92% of the animals that were caught. Sometimes they'd get shed on the outside of the device before coming in. So we had cameras monitoring for that. We want to be able to keep an eye on that.
Or you're essentially crucifying the fish though, isn't that illegal?
Yeah, so the device does remove them, naive to minimizing injury. And we've talked about solutions to that. It's something that we are recording because it's a concern. You're not allowed to crucify fish. We have some solutions to that we could pursue, both on different hook designs, different gangion designs, snap designs, where you unclip it and you leave the earring in the fish inside the device. There's a variety of solutions we could approach, but for now, our supposition is similar to problem bears. You don't have part of your community use bear-proof garbages. You have everybody use bear-proof garbages, and that therefore the thought is it might be better if there's whales present that you use the tool, and when using the tool, you don't release anybody back into the water. You don't put any crumbs in the water to try to just totally stop the behavior in areas where it's a problem. So that's kind of the route we're going. It doesn't mean we can't go the other way, and we are collecting data on those injuries to better understand what level is that potentially a problem. So we do have funding to do a further round of testing on the shuttles specifically. We did put this out to tender in 2024 this past summer, and we did not secure any bids, did not get any bids. We were able to convince the funding agency, which is a program through NOAA, to extend that funding through the 2025 field season. Our preference is to do some fishing in an area that's got known depredation by orcas, and we want to continue to look at those catch rate comparisons, test some further refinements, and just get a larger data set in an area that's relevant to the problem.
Does this have an EFB, or does it need an EFB? I guess I'm not really sure how that works with.
Yeah, it does not need an EFB. It's longline fishing. It's a different way of landing those longline fish, but it doesn't require an EFB.
And you need a serious pick and boom if you're going to do this, if you catch any fish, because you might be bringing 2,500 pounds aboard plus the unit. So you need a real boom. So
the unit weighs 200 pounds empty. It's about 8.5 feet long by 3.5 feet wide. We can take you down to look at them. They're just down the road if people are interested, even at either today after this or tomorrow after it, if there's interest. You know, the amount of fish, so they're using these devices, a larger version of these devices in the Patagonia toothfish fishery. It's an invention out of Norway. And they're packing that thing with 2,500 to 3,000 pounds of fish and then hauling it up. It is being used right now experimentally off of South Africa and another fishery. And on that one, they are using a swing davit and a kind of a ramp sort of thing to help slide it up into a boat for a vessel that doesn't have a fully articulated boom. I suspect there's ways to manage that, but we may need to get creative with boats that don't have that as an option.
So, I mean, Al said 110 fathoms. Is there sort of a cutoff where, you know, you probably shouldn't go shallower than this or shouldn't go deeper than this? What are your thoughts?
Yeah, I'm being asked to keep moving, so why don't we chat about that on the side? There shouldn't be any restrictions. They fish this thing miles deep in the Antarctic. So the last thing I'll touch on, and the hooks have been drifting around. We've been doing some cooperative work with Dr. Lamelli out of the Pacific States Marine Fish Commission, looking at these appendage hooks, trying to again reduce yellow eye bycatch while maintaining halibut catch. The hook that you saw with the timer has a 90-degree appendage on it. That had no effect in catch rates, so it doesn't really interfere. The concept here is that the two different fish have two different mouth approaches to that hook, and one bumps the hook out of the way where it doesn't get caught, and the other one does not bump the hook out of the way and it does get caught. The 45-degree offset does reduce dogfish bycatch on the offset side, but on the non-offset side, so the offset non-offset has to do with how that hook is curling back towards the shank, and typically it's not straight back at the shank, it's offset on one side. If you put the appendage on the non-offset side, you can reduce yellow eye bycatch, seems consistently by 25% while keeping your halibut catch the same. The 45 on the offset side reduces dogfish shark bycatch, but has no effect on rockfish. And so we're looking at doing some further testing of these devices. I have a few proposals out there to that end. And the hook timer is showing that, again, most fish on this work were caught in less than 2.5 hours. Some of the work that they did with the floated gear this summer, it was 90 minutes. So, and you can find more information on those hooks at that publication. But can I move on? Okay.
Yeah, let's save some questions for later, but we want to make sure that we cover the rest of the presentations this afternoon. So if we can move on to the next presentation, that would be the monitoring section.
Just on that, we have fishery dependent and fishery independent monitoring. Basha, did you want to talk a little bit about e-logs just while Tyler gets set up? Come on up, Tyler, you're okay.
Sure. Thank you very much. Yes. So in terms of the fishery dependent data, I'm happy to answer any questions, but we don't have any specific presentation. We typically do not provide these for RAB. But I just wanted to give an update on the IPHC trial project using electronic logbooks. As you might have seen in the field, IPHC started using electronic logbooks provided in collaboration with a company called Real-Time Data, or known as Deckhand. So we introduced a new version of that electronic logbook via Deckhand that is an equivalent of the IPHC logbook. So now this electronic logbook is available as a replacement of a NOAA logbook for vessels over 60 feet or using long line pods, as well as for smaller vessels that have been using the IPHC logbook. So those vessels are now eligible to use the electronic logbook replacement. So IPHC has been conducting a trial. We have been distributing logbooks, those electronic logbooks in the form of a tablet directly to interested trial participants. So we distributed some. There has been also additional tablets distributed directly from Deckhand through their funding. We are fully equipped now to receive that data from those tablets directly through tablet to tablet data transfer through our field staff. So how it works is that our field staff, if you using electronic logbook, our field staff would come and just do the direct tablet to tablet data transfer through airdrop technology. And then they conduct the same data verification process as they would do for the paper logbook. So they can make, as a part of the interview, they can make corrections of the log entries directly on their tablet. This data is then transferred after verification by the field staff directly to our office, and we directly download that data and bring it to our database. So very smooth process. There are, of course, a little bit of challenges as we learn through some of them less usual situations that might not have been accommodated through those electronic logbooks. So we are working with Deckhand to accommodate these. I think one of the mentioned one was if the gear breaks, then it's been hauled at a different time. There's an option to add a comment on that, but we're still working kind of more streamlined solutions for some of these less usual situations. So this has been working really well. If you have any comments or updates on that process, we are really interested in hearing these. And I'll also mention that Deckhand will be at the Pacific Expo, and they will be giving away a number of tablets for interesting vessels. So if you want to take a part in the electronic logbook new program, and you can get the tablet for free at the expo. So Yeah, and again, we are fully equipped to receive that data in electronic format now for our field staff, as well as later after the season ends, you can also send that data from the electronic logbook directly to our office. So yeah, if there are any questions, I'm happy to answer these. Thank you.
Great, thank you, Basha. My name is Tyler. I will be standing in today for Kayla Walesi, who is also actually about to add another member to her family any day now here. So yeah, I will be stepping in and talking about the IPHC Fishery Independent Setline Survey design and implementation for this last year. I'll try to keep it pretty short and sweet. I know we're a little behind schedule. Oh, look, see, I got introduced by horns. Okay, as a reminder, the primary objective for the the FIS is standardized fishery independent data collection for the Pacific halibut stock assessment and stock distribution estimation. And we're looking at Pacific halibut distribution and abundance trends while collecting biological data that help determine sex, maturity, and age. In the 2024 FIS, both gear and bait are both standardized as they are every year. And the FIS provides a relative abundance indices critical for stock assessment models, and standardization ensures that these indices accurately reflect the changes in a population rather than the artifacts of survey methodology. Calibration studies in previous years have allowed us to open up the bid process to both fixed and snap gear vessels. However, in 2024, we only had fixed gear vessels participate. As most of you are already very familiar with, I won't go through it line by line, but we do standardize skate length, number, and spacing of hooks, as well as hook type and size, as well as we also put weights at the end of each anchored skate. And for bait in 2024, for the first time, we used both frozen chum and pink salmon in an attempt to compare and calibrate relative bait success. These baits must be number 2 semi-bright or better, and individual baits must be cut to 1/4 to 1/3 pound, and captains and field staff must work together to inspect and ensure that the bait is up to our strict quality standards, and captains have to sign off on bait quality. Okay, so here's a map showing the 2024 Fishery Independent Setline Survey. The orange dots are what were planned for 2024. And as you can see, this season's design was significantly reduced with 525 total stations planned as compared to the 958 that we had in 2023 and the 1,188 we had in 2022. And this season, it ran from the 14th of May to the 15th of August. It ended a little bit earlier because of this reduced design as compared to 2023 and 2022, where it ended in September. We had 5 vessels participate this year, and that is a few less than the 8 that we had participating in each of the previous 2 seasons. Okay, so this table provides a breakdown of the various types of ineffective stations we encountered in 2024, noting that there were 15 total stations that were deemed ineffective. As per usual, the majority of these stations were deemed ineffective due to whale depredation. So as you can see from the orange dots, those are the whale depredation ones. There were 9 stations that were victim to sperm whales. So you have 2 down there on the northwest end of Haida Gwaii that were hit by sperm whales, 1 at the south end of Haida Gwaii, and then you have a cluster of them up there in 2C under Baranof Island around kind of Point Omni. Also out in 4C, D, and E, we had a pair of stations deemed ineffective due to orca depredation. And then outside of whale depredation, we had 1 station in 2B that was marked ineffective due to gear issues. I think that was, to no fault of the vessel, but just didn't get enough hooks back, lost some gear. And then those 3 circles that you see in 2C of the inside waters up there, those were those ones we spoke about earlier that were deemed ineffective due to sand fleas. And I'll actually pop to this next one. So as you can see, on the last side, I had noted that we had 15 total stations deemed ineffective in 2024. But how did we compare when we looked at years previously? So this graphic kind of gives you a visual representation of the percentage of stations that were deemed ineffective year to year, starting in 1998, running up until this year, 2024. And that navy blue color that you see is the whale depredation. And as you can see, it's generally the predominant reason why stations were deemed ineffective. If you look back farther in the timeline, that yellow part of the bar is actually, we had a lot of sleeper sharks, I believe. But yeah, so we usually, as of lately, had a lot of problems with whaling. So and particularly when we sampled in area 4, and even more specifically in 4A, where we have the highest percentage of ineffective stations. And I would like to note that we did not perform the FIS in that area in 2020, 2023, or 2024, so that you do see a little bit of a reduction in total ineffective stations in those years. Also of note, this year we did see a significant increase in sand fleas coast-wide. And as we spoke about earlier, only 3 of those stations met our strict criteria to deem them actually ineffective. The secondary objective that we have at the FIS is currently long-term revenue neutrality. So obviously, if money were not an option, we would of course prefer to have a FIS design that had a completely comprehensive coast-wide footprint, but we realize that currently isn't feasible. And as a result, the size and breadth of the FIS design is highly dependent on getting the most out of our dollar. So I think Dr. Webster will probably speak a little bit more on the next presentation about that, but we strive to meet this objective through a number of measures to reduce costs and increase revenue. This is achieved in our fish sale process, where a request for tender is sent to all buyers that are able to buy fish in a particular port to ensure we get competitive pricing. All bids are rated against specified criteria provided to all interested buyers on the notice, and we have established protocols for review and approval for each sale. So starting in 2023, we also opened up bids to multiple ports to increase options and take advantage of local pricing. I got some dirty looks when I said that. Not some of our captain's favorite thing to have to run to ports they weren't planning on, but it does give us the opportunity to try to get the best price. When contracting vessel charter agreements, we follow kind of a similar approach by submitting them to a bid process, and all submissions are rated against specified criteria published in tender specifications. We further tried to meet this secondary objective by selling all sampled U32 Pacific halibut, and those are fish that were already sacrificed for science, and we get about a 19% less for those fish than we do on the legal size fish. The tertiary objective of the FIS is scientific collaboration. This year, coast-wide, we took Pacific cod and spiny dogfish measurements. In previous years, we collaborate in 2B in a dockside rockfish sampling program. And in years that we sample in Washington, we collaborate with WDFW to fish 8 rockfish index stations and participate in a dockside rockfish sampling, which is also on hold in 2024 because our design did not cover any stations in 2A. And yeah, this link just provides, or this slide just provides links to our website that will show you the 2024 FIS results, as well as the results from all previous FIS seasons. Okay, so as I mentioned earlier, the size of the footprint in subsequent years is highly dependent on the proceeds from fish sales. The state of the FIS mostly hinges on 2 variables that we pretty much have little control over. That's how much fish we catch and the prices. So if we want more FIS coverage, we need to either catch more fish and or get better prices. So as we look forward to 2025, we need to evaluate our second objective of revenue neutrality. In this graph, you can see what we actually caught in the navy blue bars versus what was caught last time those stations were fished, and that's the yellow. There is a kind of a big disclaimer here, and that is that these totals are strictly from raw fish catch data. This is not corrected for anything like bait competition, and some of these stations haven't been fished in like a lot of years. So this really shouldn't be confused for basically the actual catch rates for the survey, but it is useful when kind of looking at revenue. This graph also includes vessel captain stations in 2C and 2B. And if you guys are unfamiliar with that is, it's where for each full day of fishing, captains were allowed to replace one station that was on the grid with a nearby location of their choice that they thought to have either better catch or increase or have advantages in efficiency. And pretty much, yeah, as you can see, overall, we caught 88% of what we caught coastwide at those same stations last year. So you can really see this vessel captain effect, but you can see that here we caught 88%. That total coastwide was really aided by those percentages in 2B and 2C. And you can really see this effect when you compare that to the next slide here that doesn't include vessel captain stations. So as you can see, 2B and 2C, there's a big discrepancy there. So I don't think it's any surprise, but when fishermen are kind of left to their own devices, they're really good at finding the fish. So yeah, big difference, right? And here, when we exclude the vessel captain stations, we only came up to coastwide of 69% of catch compared to last time those same stations were fished. All right, so now that we've considered catch, the other side of the revenue equation here is price. And I won't go through this line by line, but if you look at 2C and 2B, where we catch most of our fish, when you compare 2023 to 2024, there is quite a big reduction in 2024 in price. But if you go down to the coastwide totals average overall, it did seem to stay pretty consistent. And also note that these prices in 2023 have been inflation adjusted to provide a consistent basis for comparison. Okay, so this graphic provides a look at the average price pattern beginning in 2000 all the way through 2024 FIS. You can see that early on, there's quite a bit of fluctuation over the years. And I think really looking at this, the takeaway is that as you get to the last 2 years, it seems like the prices have gotten real sticky, right? So prices haven't changed yet, despite operating costs going up. The costs or our prices that we get haven't really rebounded to pre-pandemic levels. That's adjusted for inflation as well? Yeah, that one's adjusted for inflation as well. So Pacific halibut sales USD by IPHC regulatory area. So you can see that in 2023, fish sales, we earned about $3,173,000. And in 2024 total, we earned only $2,100,000. And this isn't too much of a surprise to see that big decrease, only because we fished only 55% of the total stations that we fished in 2023.
Does that 3 million on 2023 and also include that additional fishing you did in Southeast?
That one does not, no.
Okay.
I thought you just did the captain stations.
Well, I think the reason why we only did it in area 2B and 2C is that's the areas that we thought that we would get the most benefit in catch rate. I don't know if, unless this might be a better question for Ray, but that was essentially what we came down to. I know you were chomping at the bit to probably try to do some of that in 3A and 3B, huh? Yeah. Seemed fun. Yeah, what's that?
Would that have looked like normally you do 3 stations a day and this allowed them to do a 4th station?
Yeah, it could look like that. In most cases, it actually worked out that they had to do at least 2 stations on the grid. So we're still asking the eight skates. So they were still fishing 2 stations that were on the grid and then 1 station that was off the grid. And the feedback that I got is that they did finish a lot earlier on those days. But I think Ray will probably touch on this maybe a little bit later, but I wouldn't get your hopes up for another year of doing that. You guys were actually too good at finding the fish. I know.
I have a question.
Yeah.
If I remember right, the reason we fished less stations was because of a lack of funds. But it seems like we also made less money because we fished less stations. Does the money saved from not fishing those stations make up for the money lost from not fishing those?
Yeah, so we end up, even though we made $1 million more, we spent a lot more than $1 million on, just the cost of business, chartering the vessels, paying the field staff, so on and so forth. So we spend a lot of time crunching the numbers and trying to find a theoretical break-even point, right? So that's really what that's the mark we're trying to hit. If we fished everywhere, the whole 1,800 stations, we would make a lot of money in catch, but it'd be pretty expensive. So that's unfortunate. Okay, so we also had some highlights in 2024. The FV Kimasu, yay! Lando, he had completed 169 stations, and he shouldered all the work of 3A and 3B in charter regions Albatross, Shelikoff, and Trinity, and he had 0 stations deemed ineffective. Also of note, we had a very low percentage of ineffective stations this year, with only 2.87% as compared to 3.25% in 2023 and 4.96% in 2022. Of the 525 stations planned, we had 15 stations deemed ineffective and 3 stations unable to be fished due to locations in protected areas. So that gave us 507 stations completed effectively. The 2024 FIS did have some challenges. We had poor catch in all regulatory areas, especially when you excluded vessel captain stations. And we had also unfavorable prices again for yet another year, while overall coast-wide average price is slightly higher than in 2023. Pricing in higher catch areas was still lower than last year. And that concludes my talk. Any questions? Yes, Brian.
Why do you have stations in protected areas?
So we have 2 of the stations that weren't fish are in Glacier Bay National Park. And we don't want to take them out of the design because every year we submit for a permit to try to fish them. So we hope to fish them, but we don't always fish them. And then there's a station in 2B, I think it's St. James, that there's a protected area where we fish for a rockfish MMPA, rockfish protected area. And it's like smack dab in the middle. And that is something also that we submit to try to fish, not always allowed to.
I know last year it was presented that we were going to do the different types of bait, the pink salmon versus chum salmon. How did you did you actually compare it? Was there a comparison
Yeah,
study?
so it might be discussed in Ray's presentation, but I'll steal his punchline and tell you that they wasn't worth it. So as I think we got a lot of feedback from fishermen that said that it probably was going to have lower catch rates. And lo and behold, it did have lower catch rates, and it didn't make up for the amount of money that we were going to save when using pinks, especially because chum salmon price has gotten lower recently. So there wasn't really that much of a benefit or advantage from actually fishing pink salmon. But I think it did give us the opportunity to calibrate these baits. So going forward, if we try to consider this again, we can do another cost analysis, and we would be able to potentially use it in this assessment.
Did you stake the pink salmon or did you fillet it?
I think they did both. They got hard because they had to be real creative with them because they were a little bit smaller. So we have the strict standard of being 1/4 to 1/3 pound of each specific bait, right? So that's really, all the guys are really used to how the chum breaks up for that. You know, they have their 4 chops, cut in half, 4 chops, easy peasy. This one they were doing, I know that in order to get the most out of the bait and get as little amount of wastage as possible, they were trying all sorts of stuff. And I guess, Lando, you're saying they were doing both staking and filleting. Yeah. So yeah, I knew it took a while to kind of dial it in for sure. It wasn't easy. And it sounds like not all of them are coming back on the hooks. So you're probably losing a lot of the pinks once they were thrown into the water. So that we do account for though, because we count for all the baits that are coming back on our 20 hook count.
Is there going to be another presentation where we can talk about survey design and stuff? Is that
Yeah, the
coming up?
next one will be dedicated to survey design. Right? Okay. Any other questions? Good. Wow, easy. Thank you.
This one. Yep. Thank you. Good afternoon. That's loud. Good afternoon. I'm Ray Webster. I'm statistician here at the IPHC, and I will be talking about survey designs. Note that this presentation was prepared before the special session at the end of last month. So things have kind of moved ahead of where this presentation was, but if you're interested in the results of the special session and the design that the commissioners chose for 2025, that is in the special session report. It's also discussed in the interim meeting documents, which will be presented next week, but are already on the website along with accompanying presentations. I'll try to describe that as best I can within this presentation, but I don't have the accompanying slides. Okay, Tyler's done a great job of saying a lot of this stuff already, so I'm going to go through this really quickly, but if this is our most important source of data, we use it for indices, biological data for the assessment. We've had an annual FIS since 1993 with expansions over a couple of periods of time. And I am messing this up. Where did it go? Sorry, I might need some assistance. I accidentally clicked something and it just disappeared.
Put Explorer.
It is Explorer?
No?
I don't know. There's so many tabs open. I don't don't touch anything on the computer. Okay. It might be the next one. Great. There's 2 more over there. We're like.
Otherwise, just use this one, right?
Well, I just got rid of the whatever. I'll just look at the screen.
Yep.
Yep. Okay. Thank you. No, I had. Okay.
Just use this.
Okay.
Just the eyes down the bottom of the screen.
Oh, thank you. All right. Thanks for your patience. So as background, at the Commission work meeting in September 2024, the Commission was presented with 3 sets of FIS designs for 2025 to 29 potential designs. 2 are based on rotating blocks of stations. We call them the base block and the core block designs. And another using reduced FIS coverage based on what we implemented in 2024. These sets of designs were intended to represent FIS coverage achievable under different levels of available supplementary funding. Given that none of the designs were projected to either make money or even break even. Here we focus on two designs considered by the Commission, the base block design for the next 3 years, which provides extensive sampling coverage over a 3+ year period. We're not sampling everything every year, but by rotating areas that we are sampling over a 3-year period, we're getting extensive spatial coverage. And a fiscally viable design for 2025 that includes sampling in all IPHC biological regions for lowest projected cost. This is the full FIS grid in orange and 1,890 stations. Thanks. And we generally augment our own survey data with data from the NOAA Troll Survey and the Bering Sea each year. So we have finite resources. We cannot sample the full FIS design every year. Particularly in recent years, we've had significant cost constraints on what we can actually do. So we prioritize our sampling effort based on scientific needs, precise estimates of indices and stock distribution with low potential for bias. And that may require more frequent sampling in areas with higher variability or often areas with higher density. And long-term revenue neutrality, increasing effort in revenue positive areas to offset the cost of sampling low-density habitat, or potentially reducing effort in high-cost areas to avoid large deficits. And we've done both of those things in recent years. I'm going to skip this slide because Tyler did such a good job talking about our objectives. So the optimal 5-year rotational design. The base block design was presented to commissioners at the work meeting this year for 2025 to 29, 5 years ahead, so they could see how it would pan out over a longer period of time. It prioritizes some annual sampling in each biological region for stock assessment purposes, ensures all data regions in the core of the stock, 2B, 2C, 3A, and 3B, are sampled over a 3-year period, resulting in CVs, which is a measure of relative precision of things, for abundance indices, and of no more than 15%, which is quite low. Coverage in other areas is prioritized to minimize bias potential. That is what we're estimating is representative of what we want to estimate, and maintain CVs below 25%. So a little more relaxed on the precision limits outside of the core of the stock. The sample blocks, which we're using charter regions for, are rotated over time. This design is projected to maintain precise estimates of indices, as indicated by those CVs of Pacific halibut density and abundance across the range of the stock. By rotating the sample blocks, almost all fish stations are sampled within a 5-year period, 2 to 3 years within the core of the stock, resulting in a low risk of large bias in estimates of trend and stock distribution. If there are changes that we haven't seen because we didn't sample an area in a given year, we're going to catch up next year or the year after by sampling those areas that we missed. And this is what those designs over the 5-year period would look like. So you can see how the sampled areas change from, okay, thanks, Joseph. Sampled areas, I will not touch that. Sampled areas change from year to year, but we are covering, if you put the piece all these together, you would see quite comprehensive coverage over that 5-year period. Most of the stations, almost all of the stations would be sampled. There are some stations that don't fall within that 5-year period because they have extremely low densities, such as the inside waters of 2B and 2A. But they would be eventually picked up in a slightly longer sampling period. Okay, so we presented this to commissioners as sort of our optimal rotational design. But projecting costs for 2025, we implement that design, we were expecting to lose in the order of $2 million. So this was not fiscally possible without a large influx of supplementary funds, which were not forthcoming. So we looked at a fiscally viable design. Last year, we talked about a revenue neutral design. There was no such design based on the updated projections using the information from 2024 with updated catch rates and prices. So this would fish one charter region in each of 2B and 2C. These charter regions were projected to reduce losses relative to not fishing anything at all, because we still have fixed annual costs due to office staffing and so on. One charter region in each of 3A and 3B, which maintains some sampling in region 3, and 60 stations in each of 2A and 4A, 4B, covered by supplementary funding. So that funding was confirmed prior to preparing this presentation from the two treaty partners, well, from the US. Fiscally viable design, projected cost and revenue, still projected to lose money, but a lot less money than the more expensive block design. And we can see the total projected cost, projected revenue, and the supplementary funding, which was known at the time of writing. So we recommended to the Commission, and again, some of this has been superseded by the special session, that they move forward with the 2025 FISC design option described above, the fiscally viable design, with the assumption that additional supplementary funding will become available in early 2025, and any remaining deficit will be covered by the IPHC Reserve Fund. And should additional supplementary funding not become available, we're comfortable covering the full amount of the deficit from the Reserve Fund for 1 year. I'm just going to see what's on the next slide to see what I can say about that. Okay, so the special session, they actually went further than this. So we had a couple of other options which were significantly more costly, but would provide coverage that was perhaps more scientifically useful in terms of reducing the bias, particularly in Region 3. So these two charter regions, I think that's Trinity and Albatross, if I've got that right, were the ones that were projected to lose the least amount of money in 3A and 3B. So we put those forward as the most fiscally viable regions. But we also fished those in 2024. So they're not providing us something that we didn't see already in the last year or two. So we had alternative designs that were to cost, they also used two charter regions that would get us to look at something we hadn't seen for at least a couple of years, maybe even 3 years. And so one of the options was to fish the western part of 3B, which I'm thinking is Chignik and Shimigan. Somebody can correct me. Senac and Shimigan, thank you. And in 3A, I think Prince William Sound and Yakutat in the central part of 3A. So regions that would give us information that was complementary to what we'd already seen in 2024. So something closer to rotating the blocks that we saw in our optimal design. And what the commissioners decided to do was include all 4 of those charter regions in the final design and pay for those using money from the reserve fund, which to the tune of $1 million. So there'll be that information is in the reports that are online. You'll hear more about that at the interim meeting next week. So I'm trying to find there we go. So it still represents a reduced design, although an improvement over the initial recommendation of the fiscally viable design. And indices of Pacific halibut density can change by large amounts over short periods, with annual changes of up to 15% or more regularly observed at the level of biological region and regulatory area. Over a 3-year period, large changes in indices of density are the norm, including at the coastwide level. So if we're not sampling an entire region or entire regulatory area, there's a high potential for changes to occur over a short period of time that are unobserved. And if we don't observe them, that's going to lead to indices that are biased. They're either going to be higher or lower than what we would have got had we been able to measure the full spatial extent of the stock. So designs such as that implemented in 2024 and the proposed fiscally viable design therefore have high potential bias in area, regional, and coastwide estimates. And 2025 would have been the 2nd or 3rd year with reduced coverage for much of the stock. So this is mitigated a little bit by the design that the commission actually selected. So particularly in Region 3, things are better than they could have been under the fiscally viable design, but it still represents a reduction in coverage compared to what we've normally seen. The potential for bias, while lower, is still there. So again, this is a little bit superseded by events. Fiscally viable design would have resulted in about 60% of habitat covered by either the FIS or the NOAA trawl sampling that we anticipate in 2025. With this coverage and observed levels of change shown in previous slides, we would expect coastwide indices of abundance to have a bias of up to plus or minus 15% following the 2025 FIS. So that coastwide level, regardless of any uncertainty, there's always uncertainty in the estimates. The values could be 15%, up to 15% higher or 15% lower than the underlying true values had we been able to measure them. But it would be worse in biological regions 3 and 4, which would have had the lowest coverage. Again, things are better under the selected design for region 3. Something Ian can speak to more, but Ian has done analysis regarding the impact of bias in the reduced coverage of the survey design on the potential for bias in the assessment. I'm not going to go into detail on this slide, but we'll be presenting this material at the interim meeting next week, and the material is available for you to review online. So we recommend that you note the paper that presents the designs for the next 3 years. I will add a couple more things since it came up in Tyler's presentation and might preempt some questions, but also refer you to the space-time modeling results presentation for the IM. But that presentation contains information on the effect of vessel captain stations on estimates and the differences between the two baits and how that varied geographically. Regarding the baits, chum versus pink salmon, there was one IPHC regulatory area where there's virtually no difference in the catch rates, and that was 2C. They basically did as well as each other, and with the chum costing less, then that's still a viable alternative in regulatory area 2C. And you probably have more knowledge of why that might have been. Maybe they're more experienced with using pink salmon in 2C than they are elsewhere, but they were the same. 2B, a little bit less pink salmon catch rates than chum. Elsewhere, the catch rates of pink relative to chum decreased the further west you went, with pink salmon baits catching perhaps even as low as a third of the catch rate in 4CDE. So that is one of the factors leading to the differences in overall catch that Tyler showed in the slides with the yellow bars and the gray bars, is that the pink salmon baits were catching less than what we would have got in general than if we had been using chum everywhere. That is accounted for in the modeling. We make adjustments to account for the bait. We are using all of those data from both baits, but essentially predicting the indices as if we had just been using chum. Regarding the vessel captain stations, the vessel captains were very good at finding little spots with much higher catch rates on average. And were we to include those, we fitted models with and without those stations. And this was a concern that was raised at this meeting last year and also in public sessions at the annual meeting this year, that these stations have the potential to introduce bias into the modeling. And those concerns were borne out. We thought there was a chance that that because the modeling is heavily influenced by what was caught last year and nearby stations, and we're predicting at the stations on the grid, regardless of whether they were fished or not, we're not getting a prediction for the indices at the vessel captain station locations, that there may be little bias, if any, just for over a 1 year period. But in fact, I believe, if I remember this correctly, vessel captain stations indices were up to 13% higher if we included the data from vessel captain stations than if we excluded it. So the models were, the official output from the models were based on models fitted without data from vessel captain stations. Still were useful in terms of increasing revenue, but and I believe Ian is using the biological data from those stations. Is that he's not using the biological data from the stations? Because another point was that it seemed that from the analysis that vessel captains were able to target areas with not only higher catch rates, but they were higher because they were catching larger fish on average. So it changed the size distribution of the catch, which would affect Ian's modeling. So the numbers per unit effort were almost identical between vessel captain with and without vessel captain stations in the modeling, which is to me was a very interesting result, but maybe not surprising to some people. So yeah, I just wanted to add that maybe preempt some questions or maybe open up some other potential questions, but happy to take questions now.
I'm just curious, last time when we did a survey, the captain had a set on north, south, east, west access. You couldn't deviate from that. Is that still the case?
Tyler, it's
I mean, you're supposed to default to north, south, or east, west, but there are situations where when you can't do that, you can still fish diagonally for reasons like tide or, land or depth, things like that. So you can still technically do it, but yeah, you're supposed to default if you can north, south, or east, west.
Okay, the reason I bring that up is the captain stations. Were they supposed to kind of abide by that north, south, east, west access, or could they go hog wild on that as well?
No, yeah, they were allowed to go in any direction.
I mean, this seems really nothing more than a revenue generator. This doesn't sound even close to being standardized, that captain station.
I mean, in other respects, it was standardized in terms of bait and timing and all that kind of thing, but that was the motivation behind them. We were asked to find ways to make the survey more efficient, to possibly generate a little bit more revenue, and there weren't many ways that we considered actually feasible, and that was one of the things that seemed like something we could actually implement. So we tried it. We won't be doing it again in a hurry.
Yeah, and I'll just add that that's exactly what it was. It was in addition to what's already been mentioned. It was there to try and ensure that we were as close to revenue neutral as possible. And even with that, with additional contributions from the contracting parties of about almost 200,000 last year, we were still negative. And so it allowed us to do some more sampling in a standardized fashion in other areas.
I'm sorry. In the case of like 4B, it's been several years since we've had a survey there, or even a trawl. I mean, to my knowledge, correct me if I'm wrong, it's not even a trawl survey, right? So we're still working off extrapolated data. I see you're having a little bit of in 2025, a little bit of a survey there in the eastern part, but it seemed like the last time there was a survey there, you guys are concentrating on like the passes, areas that you aren't able to fish all the time. I don't know, it just seemed like, again, it wasn't a very big snapshot of the area.
That's correct. And that wasn't our intention that year. We had hoped to fish not only the central part of 4B, the passes and Bowers Ridge, but also the western part of 4B, the R2 region. But we didn't get any viable bids for that part of the stock. So prior to that, we had some surveys in the eastern part of 4B, which is where the highest density is. And so that's been our focus for getting sampling there. And that's why we have those 30 stations. We would like to do a lot more than those 30 stations in 4B. But you're correct. And that's resulted in an index that we don't know how close it is to the truth anymore. There's a lot of uncertainty. It could have been changes in the stock that we're completely missing, because it's been by 2025, 3 years before we've seen it anything but the central part of the stock where there isn't much fish. So yeah, there's a need for a better understanding in 4B, and hopefully we can get resources to do more extensive surveys there in the future.
Just to comment on that, yeah, in 4B especially, it really feels like we're chasing fish that aren't there, and you end up fishing in riskier places to accomplish finding those fish for passes that you can only fish certain times of the month or even certain times of the year. So just wanted to add that.
I was going to say it would be really interesting, or I would like to see a plot of the stations that will have been unfished for more than 3 years, given next year's design, 3 or more.
That's a good suggestion. Appreciate that. Yeah, we can put that together.
I think this would be a good time to have my annual plea for recruitment for boats for 4A, 4B. So as you saw, we do have supplementary funding that's covering 4A and 4B, but that doesn't do us a lot of good if we don't get any bids out there. So please put out the word to anybody that's interested that that's obviously a very high priority area that we haven't fished for a while. So there'll be 60 stations out there, and talk to Claude too if you want to maybe be interested in he wants to piggyback the cash protection study off of that too. So you can get a good chunk of work off of doing both 4A, 4B, and cash protection. So think about it, please.
I second that.
When you estimated your costs and net or negative revenue for 2025, what did you base that on? Did you base it on the last bid you got for the area? Did you adjust for inflation? How did you arrive at those numbers?
Yeah, we assumed no bid inflation, and we assumed, I think, flat price for the next year, but we did assume an additional 5% decline in landings. Obviously, we don't have a crystal ball either. So if we knew what the price was going to be next year, we'd be in better shape.
Stuff you have online, you have supplemental funding for 4A and 4B that's different than, where's that coming from? Card games?
No, that's supplementary funding that's being directly provided by U.S. State Department through appropriations of Congress. Yeah.
Why is it specific to that region?
So it's specific to Region 2A and 4AB was the two areas that the U.S. has requested that the funds be applied to. And that was because the original proposals that we put forward that would be close to revenue neutral didn't include those two areas.
Well, I think I've told this to Ian, and I'll say it again. Some data is better than no data. And I think you're going to have a hard time convincing anybody to fish the footprint you have out there. I mean, you've bid it before and people have done it. I've done it. Other boats have done it. And well, most of us are saying we'll never do it again. So I don't know, the footprint you used to have there, I think we talked about this a little bit before. There were some stations that hit on odd years that weren't in that region that were fishable. So I don't know, maybe you got to take another look at that going down, next year or something. I don't know what that does to your bias or any of that kind of stuff, but there's some good fishing around that aren't down deep in 4 mountains that you can only fish 1 week a year with any success, and that's not even including the whales. So I don't know. Yeah.
Our thinking on putting those two areas together was that we wanted to get some sampling in both and have contiguous stations so that if somebody bid on it, they didn't have to do a little piece of 4A and then run for a week to get out to the end of 4B. But like you said, I think we would be happy with 30 stations anywhere in 4B. Doesn't necessarily have to be those. Those are, in recent years, have been the higher catch rates. And so we're going to get the most return in terms of scientific information as well, because we're going to nail down where the biomass has been in recent years. But none of us are satisfied with this design either.
Does some of this big picture indicate a constricting of the biomass?
Well, I'm not sure we have a comprehensive enough survey to say definitively because we've had so many gaps in the last several years. But the data that we're getting are consistent with the longer term trend, which is a shift of biomass from the west to the east. And we've seen that trend for almost 20 years now, of where we used to have high biomass in 3B, Western 3A, 4A. We've seen a shift over time. And it continues on. So I don't think there's no evidence right now that we're seeing a different pattern than we've seen. But it's certainly been a sparse enough design for the last couple of years that it's difficult to tell.
So in the economics of this whole discussion and where we're trying to get to zero or neutral funding, is what is the most cost-effective way of doing that in the research aspect of it as a board? What research could possibly be paused? Or what's your most expensive research opposed to bang for the buck type of thing? Do we need to have a discussion as to what research is the most, in your scientific opinion, the most valid, or not valid, but the most important to the industry and to the longevity of the commission and to just the whole program, opposed to, and do we need to start looking at paring down something and to get to that zero funding?
Yeah, I think we're talking about slightly different pots of money. And so for the research side, which Giuseppe and co have presented today, that comes from our contracting party annual contributions to the general fund versus the Fishery Independent Setline Survey, which has historically been self-funding with supplemental funds coming in from other sources, whether it be State Department or DFO. And so when we're talking about whether we need to reduce the research related to the FIS, we're talking about the footprint, or maybe removing one setline survey specialist from each vessel, which means we reduce the amount of data that's collected. And that has been done in a number of areas. But the avenue that we feel we have to go to at this point is really looking for significant supplementary funding from the contracting parties. And so we have calls out to both contracting parties for about $2 million is what we think at the moment in the current abundance of the stock and the economics of the fishery that we'll need for the next couple of years, every year, to be able to sample adequately the base block design that's Ray and Co been putting forward. And so that's the avenue that we're really pushing, and we're pushing that pretty hard through a number of avenues, whether it's directly through the Appropriations Committee or, as I said, through the Fisheries Minister in Canada.
So that with that supplemental 2 million or so, would the footprint go back to 1,000 stations or?
I can't remember what the base block design is, but it's that 5-year rotational base block design is what we would go to. I hope somebody can read that. About 700. Yeah. And so that's essentially looking at, now I'm not sure which slide you had it on, Ray, the $2 million shortfall is just an example of what it would look like. So this is what it would look like in 2025 if we did the base block design. We know it's going to cost us around 3.8 million. We have a revenue of 1.7, and so there's a shortfall of around $2 million. And assuming all things equal and we're able to stay in that general pattern for the next 4 years or so, logic is that we would need around $2 million for each of those years until things changed in the fishery, whether it be the economics or potentially abundance as well, but there's no signs of that at the moment.
I know it's been said some data is better than no data. I'm just curious, with the NOAA trawl survey, how much weight is factored into the stock assessment when we're just relying on the NOAA trawl survey?
We treat the data from the, excuse me, we give the data from the NOAA trawl survey essentially equal weight to the data from the FIS. So they represent what we're not able, their information represents what we're not able to fish in the Bering Sea. I'm not entirely sure what you mean by weight, but it's an important input in creating the coastwide and region 4 indices, and as well as the 4 CDNX that Ian uses in the assessment.
Yeah, I guess I was just trying to figure out, like, in the event that there's no FIS in an area, now all you're relying on is the trawl survey. Perhaps it goes on for a couple, 2-3 years. Just wondering how much of that is weighed in the stock assessment. I mean, how much is extrapolated data weighed in? How much is the trawl survey weighed in? Does this make sense?
Yeah, so if we're not able to do our own survey, that increases the uncertainty in the indices. And that uncertainty carries through into into Ian's assessment. And also, presumably we have less information on biological data from those regions as well, which plays through into the assessment. So, yeah, you're right. Sometimes the littoral survey is the only thing we have in the Bering Sea. That was the case last year, I think, right? Yeah. But we have calibrated that. We have calibrated those two indices, the FIS and the troll survey. We've fished them in parallel twice in 2006 and 2015, and they gave consistent results and allows us to use the troll data in a way that's consistent, create an index that's consistent with the index that we're getting. So we're pretty confident with the way we're using those data. Interestingly, they're changing the troll survey now in terms of design and configuration and so on. So in the future, we may have to do. It would be ideal if we were able to do another calibration with the new revamped troll survey. In the interim, we may be doing like a second level calibration. Like their calibration of their new troll survey with the current troll survey, and then our calibration with that in order to piece together something. But that is something that's on our radar and is perhaps of some concern to us.
Looks like everybody's in need of a drink. Of coffee. Well, that's probably it for today. I think there's a lot of food for thought there. And then this evening at the function, we can all maybe express a few other things and ideas about what we can do for the survey in future, and talk a little bit more about some of the funding issues, particularly what's on the screen there, and the shortfall between cost revenue and what our net position would be. So unless there's any other questions on any of the topics today, Giuseppe, do you have anything you wanted to add otherwise? That, we've got 10 minutes. Yeah, just open the floor for further questions. I know that there was a section from Claude on the whale depredation hook appendix that didn't really have much time for questions. This would be a good opportunity, if not later on, or let's remember that tomorrow morning we start with the continuation of the discussion. So there's additional time for questioning and discussion. So Steve.
I can wait, but I'm always interested in
we've got a few minutes.
Fecundity. We know where they spawn. We know they'd rather spawn than eat, or they'd rather more particular about where they eat than where they spawn, which makes sense to me. But what I want to know is the egg maturity level. What happens at the end of the cycle? Is there a time when older halibut, female halibut, they make as many eggs, but what's the fecundity of those eggs? I thought you were going to speak to that, but I didn't hear anything. But I don't hear that well.
That is a great question. There is a thing called senescence that has been found in other fish species, where they can get to a certain age and then they stop spawning. We have yet to see that in Pacific halibut. We've collected 3,500 histology samples now. And I haven't seen a single female that's showing presence of senescence at the older stages. But it definitely is something that's possible, that's out there. The one thing that histology has given us to improve our estimates is that it's helped us improve our ability to see younger, mature females, but also our ability to see immature, older females. So if you recall the current ogive that Ian's using on our assessment, once we hit about age 15 or 20, between 15 and 20, we're assuming almost about 100% mature. But we know that not to be true now. I have seen multiple females that are above the age of 20, 25 years old that are actually immature. that have never shown any sign of previous spawning. So that's something that histology has given us to improve our estimates for maturity.
Yeah, one of the things that Colin alluded to before is our plans to look at fecundity, and particularly, I think Dave also mentioned it just recently, that we conducted a collection study in the fall of this year. So that was wrapped up about a few weeks ago. That was destined to collect fecundity samples from large females, so that we would have a decent range of sizes to, test the idea whether larger females proportionally produce more eggs, as Colin mentioned before. But the senescence aspect, we don't know. We don't know whether older females after a certain age produce less eggs, stop producing eggs, or actually produce the same number of eggs with lower quality. That's another question that we can't really investigate very closely. Older females could be producing exactly the same number of eggs, but those eggs may not be 100% viable. So, if you just look at fecundity, if you just count the number of eggs, you're going to get an egg output for a female that maybe the survivability of those offspring is not 100%. So that's another thing to think about. And potentially that happens when females get older and older and older after a certain age, which we don't really understand yet. So, but that should be something exciting coming up next year, is to introduce not only, those changes that you saw today on maturity schedules regionally and temporally, but also first estimates of egg output per female.
I'll just say we did catch, what was it, 218 centimeter female in northern 2B in October, and it had 18 kilogram gonads. So I don't know if you've ever seen gonads that big, but they're about 40-pound gonads.
Any more questions on any other topics for now? Yeah, Grace.
So with the maturity, it's my understanding that you realized they come to maturity on average a year earlier than we thought they did. Do we now know that just because we have better data, or is that a change that we can expect to maybe see continue? Like, will they continue in the next many years to become mature at younger ages? Or is it just that we have more data so we nailed it down better?
Yeah, that is a good question. I will note that histological methods in general for a lot of fish species have been shown to have younger maturity at age in general. So that is a trend that histology is showing. And I think it's just because it's a more precise estimate, allows you to determine immature and mature females more precisely, in particular at younger ages. Because if you're just basing on field classifications, when you're looking at smaller fish in general, it might be harder to determine immature and mature females. So that is definitely one thing. I will note though, so we have, the IPHC has been collecting field classification visual estimates of female gonads for decades now. And if you look back at some of the past IPHC reports, there has been noticeable shifts in like A50 values between like decadal changes, so like 1960s and 70s. So we do know that those values do change over time. We just don't know. We need more years worth of data right now to determine where we are now currently and how that might have shifted over like the historical data. We just don't know what that data was showing histologically back in the 60s and 70s. We just know the visual Because another step in the progress is to use the histology to potentially refine our field classifications. Because one of the questions got brought up is ultimately, how do we put this into the assessment? We could either just do a full swap and just go histology moving forward, or we could potentially use the histology to refine the field classifications. So that way we can continue the decades and decades of field data that we have in the assessment and just use the histology as a potential, do different ogive curves for field versus visual versus histology, and then, correct for any error estimates within that.
I'll say, we talked about it earlier today, and I've been listening to all of you tell stories, and it's clear that there's something changing with the movement of the halibut. There's areas where there wasn't halibut and now there is. There's areas where there used to be halibut and there's not. There are areas where there's much more large male fish where there wasn't before. And it concerns me that we're putting forth a proposal for a FIS for the next 5 years. It's really spotty through all regulatory areas. And with those gaps, we're not actually getting a clear picture of what the actual movement of halibut is and what the biomass is doing. And on top of that, there's talk of going to a 3-year assessment every 3 years instead of every single year. So I'm definitely worried about all of that.
Ditto.
Okay, so yeah, very close to 4 o'clock. I think it's time to wrap up for the day. Thank you all for being here, for your comments. I think this has been a really interesting and productive session. We look forward to tomorrow, but we look forward to this evening. So we have a reservation at 5. I think you all have received the email with the address, the name of the restaurant. It's in Stolen Way. If you haven't, just check with us. But we hope to see you there at 5 o'clock. Thank you.